of different batches, I used to analyze that. Means, mm,
So the stability and linearity you actually conduct study. That's what
yes,
you're
sir.
saying.
Yes, sir. Yes, sir. Yes, sir. I used to do studies in method validation for manufacturing of pharmaceutical products. Means after production, we used to calculate some validation.
You know what is stability?
Uh, no, sir. Means not much.
Stability means your reading should be stable over time.
Okay,
Reading
sir.
should be stable over time.
Yes, yes, sir.
So what is stable? First of all, do you know bias? All of you here? Yeah, all of you feel free to participate completely. Like Vignesh, Pradeep, and Venkat. This is, don't see it as a lecture or a formal training. This is a kind of discussion, right? So all of you can participate. So what is bias?
So bias is a thing that deviate from the during measurement.
Come again?
It's a deviation. Error side bias means.
Very good. Bias is error.
Yes.
So let me take a whiteboard, right? I think my whiteboard is visible, right? So let's say the masterpiece value is 20 mm. Masterpiece value is 20 mm. And I'm asking Fanindra to measure it. I know the masterpiece is 20, but Fanindra is saying, 21. Fanindra is saying 21. And now, good evening, Pradeep. Good evening. So now there is a bias. How do I say bias? Because I already know the true value is 20. But for some reason, Fanindra has given me 21. I don't know whether Fanindra has given me purposely, or is that the equipment Fanindra is using maybe out of order. Something wrong. So what is the bias here? 1. Am I right? And particularly here it is +1. The observed value is 21 and the true value is 20. So this is positive bias. So again, I call Fanindra next day. Next day, Fanindra comes and he gives me 21.5. Because Fanindra doesn't know that I'm giving him the same piece again and again. He just like that, normal manner, he measured and now he is giving 1.5. And now there are two things happening here. One is there is bias. That means readings are inaccurate. Readings are inaccurate. Moreover, readings are not stable. Not only inaccurate, that amount of inaccuracy is not stable. Suppose if Manindra says, this also 21, both days 21. Let me put one more day, third day, 21. Now considering only day 1 and 3, what is the bias on day 1? +1. What is the bias on day 3?
+1.
+1. Day 4, Manindra comes and day 4 also gives. Every day he comes, he gives a bias of 1. Readings are inaccurate, but stable. Do you understand now? Readings are inaccurate, but stable. If your readings are inaccurate, but it is stable, your calibration becomes easier. How I will calibrate? 21 minus 1. 21 minus 1. Now I have a formula. All the reading when I subtract by -1, I get the accurate value. Do you get my point?
Yes, sir.
When our readings are inaccurate but stable, we can easily convert our inaccurate readings to accurate readings. All that required is a calibration chart. All that required is a calibration chart. Now, what is the calibration chart is telling? All reading should be subtracted by -1. You get my point? So, if the bias is constant over time, we consider our measurement system as stable. If the bias is not constant over time, our measurement system is unstable. Uncertainty will be more. Uncertainty is nothing but error. And handling the uncertainty will also be difficult. Say, for example, a patient comes to you. You are the doctor. Patient, BP is fluctuating. BP is fluctuating. His BP is going up also, going down also. Now tell me, what treatment will you give? Will you give a medicine to bring down the BP level, or will you give a medicine to increase the BP level? What will be your choice?
Bring it down.
Who can't do anything? Am I right?
Yes, sir.
It is fluctuating, it's going erratically up as well as down. That means body is completely unstable now. When something is unstable and you can't really, set things right easily. So that is why we expect any measurement system to be stable. How, see, if I check all your BP level, do you think all your BP level will be stable?
No, sir.
Why? You have a BP problem?
No, but each one is
See, there will be variation is different. Variation is different. There will be variation. But your variation will be small. Not, it may not go to this extreme and that extreme. Going to this extreme and that extreme is, unstable. But always beating around an average is normal. Do you get my point?
Yes, sir.
So always beating around average, then your BP levels of normal. And now I can easily classify you to which category you fall. And then I can come out with a treatment idea. And in our case, in measurement system, the treatment is nothing but calibration. Do you get my point? Treatment is nothing but calibration. How can I calibrate my measurement system? Either I will correct the measurement system, or I will have a calibration table and convert all my data to give an accurate reading. All right?
Means, sir, we have to adjust the system. Means to correct one. Standardization. You are telling about standardization, sir?
Yes, exactly. Your equipment should be always,
Standardized.
maintained well and handled in the same manner. You can see sometimes, that the companies have a metrology lab where they will have air conditioning and everything, because they know that the environment can affect the behavior of the measurement system. The measurement system is so sensitive that if the temperature is more, it may start giving you, readings with more error. So they will even go to the extent of even controlling the temperature, and then only in the controlled environment you use the measurement system. This is only to ensure that the measurement system remains stable.
Yes, sir.
Understood. Right? So,
yes, sir, understood.
So you, in order to ensure the stability, what you need to do as a professional, for every equipment, depending on the usage, let's say you are using it on a weekly basis. You are using it on a weekly basis. Then every single week, you must actually use the measuring equipment and measure a standard piece, and plot your reading in a control chart. Plot your reading in a control chart. What is your standard piece? Standard piece is 20.
20 mm.
Right? Yes, so let's say 20 you are measuring. So for 20, your workpiece, your measurement system might give 20.2 or 19.8. Some value it will give. But fluctuating around 20 is good. Suddenly what happened? 1 week, Santosh Kumar, while using the equipment, he dropped it completely. And he don't want to let others know. So he just kept the equipment in the same box, and some other person tomorrow uses. Let's say Pradeep is now using. Pradeep do not know that Santosh dropped the equipment last day. Now what will happen when Pradeep is using the equipment which was giving reading close to 20, now it is giving 23.6.
Some discrepancy.
If I plot this 23.6 in my control chart, you will see this 23.6 going beyond the control limit.
Yes, sir.
That means your measurement system has now become unstable. The reason for instability is, I have told you, you have dropped it. Isn't it? Even if someone drops it, somebody, mishandles it, or an equipment is used for a longer period of time, there will be wear and tear. Gradually, your point can go beyond control limit. Do you get my point? Gradually, your point can go beyond control limit. The moment you start seeing a point going beyond the control limit, you can understand some calibration, some attention is required for your measuring equipment. Check the measuring equipment. Maybe you have to change the spring, or maybe you have to change a small component, or maybe you have to apply some lubrication or whatever.
Alignment something.
This is how stability comes, right? Since you raised the question, I talked about stability. So,
Yes,
any other question anybody would like to ask before? Or should I go to some?
Yes,
okay.
sir. Please.
Any specific question? Pradeep, you have any question to ask?
No, sir.
So you are comfortable in all the sessions? You are able to follow everyone, each one of us?
Yes, sir. Yes, sir. Sure.
Very good. Feel free to share your views and difficulties. Like Phanindra, what Phanindra did? He brought me a case which he is supposed to fix in his company. That's the best way of learning Six Sigma. So he brought the data and he just consulted me, and now I realized what kind of work he is doing. So I said I'll meet him separately, 1 hour on his topic, and that's the way you can equip you better in your field. Otherwise, we can only give you a generic example. How about others here? So Suajit, Vignesh, Venkat Rambabu, and Mageshwari, Suresh. But only attendance is very bad. So this is the problem. People, they don't like statistics. That is an example. So when we invite 30 people, only 1/3 shows interest in learning statistics. Right? Shall I take you through a presentation?
Yes, sir. Yeah.
Okay.
Yes, sir.
So please confirm my screen visibility.
Yes, sir, it is.
Yes, sir, it is visible.
Yeah, great. So let us understand how statistics helps in sports analytics. And whenever we watch a cricket match or any sports, a lot of analytics, given. Ball to ball analytics, match to match analytics, tournament to tournament, and a lot of analytics, right? Let's see how these statistics works and helps in the field of sports. Same way you can also use it. So this particular session, I want all of you to become familiar with these terms: descriptive statistics and inferential statistics. And then data worthiness, like your data should be clean, free from error. There could be measurement error, there could be sampling error. So I don't want to talk much on this because we will be teaching in the main course. But this I would like to discuss. Case study. How statistics and the Six Sigma approach is used in the field of sports. Right? I hope all of you like the sports, isn't it? You will be playing one game or the other game. And particularly the 2020 and all those cricket games, all of you should be watching. So let's see how it is. First of all, what is statistics, right? Imagine you are given a task to study how the traffic happens in a particular signal point, because the government is having an idea to do something in that particular signal point. So you took a data collection sheet and you are there on the spot continuously for 30 days, and particularly peak hour, morning 8 o'clock to 10 o'clock or 8 o'clock to 9 o'clock, peak hour, there is heavy traffic happens. So you are recording everything and carefully noting down. And now after studying 1 month, do you have a summary of the information gathered? Yes or no?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
What is this summary called? This summary is called descriptive statistics. You are describing what you have seen. Imagine you have seen a beautiful girl, right? And you wanted to convey to your friend. you will talk for 10 minutes continuously, isn't it? Same way, you have watched a situation 1 full month, and now you have to describe what is that you have observed. And this is called descriptive statistics. Do you all understand what is descriptive statistics?
Yes.
Nothing, nothing hidden, but you have observed it, and you have observed the characteristics of certain, the things that are happened in the signal point, and you are just bringing, noting it down. Say, for example, that is, you have studied over a period of, let's say, 30 days. And now what is that you have understood? On an average, 30,000 vehicles are found to cross the signal point during peak hours. Do you understand some information now? During peak hours, how many vehicles cross the signal point?
3,000.
3,000 vehicles.
Does it mean every day exactly 3,000 vehicles will pass? No.
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 Average.
3,000 plus or minus. So you are using average. Describe something you have observed over a period of 1 month. And you are also giving further information. Sir, out of the 3,000, approximately 1,350 are passenger cars, 600 are public vehicles, and 1,050 are 2 and 3 wheeler. So, do you understand? Now you have described what you have observed. This is called descriptive statistics. And see here, you are also presenting it in the form of a table. Every single date, how many vehicles you observed, how many are passenger cars, how many are public vehicle, how many are 2 and 3 wheeler. You are expressing it in the form of table, as well as you are expressing it in the form of a graph, and you are also giving a summary. Overall, 3,000 vehicles cross that signal point during peak hours, and you are saying now you are converting into percentage. 45% of them are passenger cars. What is that 45% here? The yellow one or red one or blue one? What is this?
The blue one, sir.
Blue color. The blue color is the passenger cars, and this yellow color are the 2 and 3 wheeler, and this red color are the public vehicle. Do you get an idea now? And somebody looking at your sheet quickly understand what you have observed over a period of 3 months or over a period of 1 full month. This is the advantage of using statistics, right? So what is statistics? Statistics is the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decision. All of you are with me now. What is statistics?
Yes, sir.
Very good, right? So every time you collect data, and every time you organize the data, like tabular column or something, and every time you present the data, analyze the data, and interpret. Like how are you saying it is 45% of them are passenger cars? You have interpreted, isn't it? This is called statistics. And now, you can also shortly say a collection of numerical information is called stats. So these are the numerical information, all that I've explained. Right? All right. So now, basic statistics. There are, you can calculate many statistics. You can calculate the mean means average. You can calculate standard error of mean. You can calculate standard deviation. Just with the help of the data, you can calculate a lot of statistics. Ultimately, your idea is to summarize the data with the central value. You remember, 3,000 vehicles are crossing. What is the 3,000 vehicle? The average number of vehicles every single day. 3,000 is average. That means what is that? Mean. And you can also assess the degree of variation. Every day, 3,000 vehicles are going. It doesn't mean exactly 3,000 are going. One day it will be 2,900. One day it will be 2,950. One day it will be 3,100. So there will be variation. You can quantify the variation so people can make a judgment on the lowest and the highest value. Do you get my point? Why we need variation? If I say standard deviation is, let us say 100, it simply means on any particular day, you can expect at least 2,700 vehicle and maximum 3,300 vehicle. Do you get my point? How do I say 2,700 and 3,300? Can one of you tell me?
Is it 3 sigma, sir? 1 sigma
Very
is
good. 3
100.
sigma. Beautiful. You got it. Plus or minus 3 sigma used. When sigma is 100, plus or minus 3 sigma will be plus 300 or minus 300. And you will be surprised to see that is exactly happening. You go and stand on the same signal point one day. The number of vehicles crossing the signal point will be between 2,700 and 3,300 simply because you calculated the average based on your 1 month study. You calculated standard deviation based on the 1 month study. So the statistics can help you to predict the situation. So either you predict the situation using the mean value, which is called the central value. Another thing is the standard deviation, which is called degree of variation. Third one, you can explore possible difference between groups. You have a signal point. Let us say there is one more signal point. In the other signal point, same study you are doing, but you are observing that on an average only 1,000 vehicles are crossing. That means the first signal point, the traffic is heavy. The second signal point, there is no much traffic, isn't it? How are you able to say there is a traffic here and there is no traffic here? You are comparing the average. Do you get my point, all of you?
Yes, sir.
Very good. So see here, there are so many statistics I have written. Now, whichever you are familiar with, you can take it granted. And anything you don't know, you want to learn from me, please ask. Do you know about mean, all of you?
Yes, sir. Yes, sir.
Mean
Yes,
is
sir.
known, right, to all of you?
Yes, sir. Average.
And standard error of mean?
Yes, sir.
Do you know standard error of mean? All of you know standard deviation?
Yes,
So
sir. Yes, sir.
standard error of means. What is standard error of means?
I'll tell you. So standard deviation is one thing. And there is another thing called, see, standard deviation is nothing but error. Nothing but error, right? Otherwise, you can also call it standard error. Standard deviation can also be called as standard error. Imagine I have
Standard error means minimum minus maximum.
No,
maximum minus minimum.
No.
That's range.
Standard, see, imagine I want you to, I am collecting, your, let us say, your blood sugar level. What is that I'm collecting? Your blood sugar level. Continuously for 30 days, I'm collecting your blood sugar level. So 30 readings I have.
Yes.
Now I will know your average blood sugar level. I will also have standard deviation of your sugar level. All right?
No, I want the clarification on the standard deviation.
Standard deviation means you have 30 data. You calculate standard deviation of the 30. You learned the formula, right?
Okay.
Square root of summation of x minus x bar the whole square divided by n minus 1.
Okay.
Using 30 data points, you can calculate standard deviation. Let us say your average sugar level is 100. Standard deviation is 5. Now you will be able to see all your blood sugar readings fluctuating between 85 and 115. 85
and 115.
115. In case you see a reading below 85 or above 115, that could have happened because of a specific reason. The particular day, you might have, the previous day, you have taken the dinner very late. You get my point?
Yes, sir. Yes, sir.
Or
Yes, sir.
otherwise, your daily routine, somehow you deviated. So only those days, you will see your reading going below 85 or above 115. Or otherwise, your sugar level will be always in the normal range. So this is what we say plus or minus 3 sigma limit. 99.73% of the time, all your readings will be within the 3 sigma limits. So this is one thing. And now my prediction is better. Are you able to appreciate my prediction about your blood sugar level?
Yes.
Now, another 1 week, I am going to do a study again with Maheshwari. Your name is Maheshwari, by the way.
No, sorry, I log in with my
What is your name? What is your name?
Shivakumar.
Oh, your name is Sivakumar. Okay.
Yes, sir.
Let me change your name.
Okay.
So, okay. So what I do is, next 30 days, I just take the sugar level of Sivakumar, right? Every day, I just don't take, single reading. Every day I take 3 readings. Every day I take 3 readings. And ultimately, after 1 month, I will have 90 readings. All of you are with me now?
Yes.
Every day I am taking 3 reading. And every day, out of the 3 reading, I will calculate an average. Day 1 will have an average. Day 2 will have an average. Day 3 will have an average. Now, how many average I will have?
30.
30 average. Now, tell me, which reading will help me better? The previous case or the new case?
The new case, sir. New case.
Because the new one, I have sample average. Earlier, I only had samples. Only one sample. If you have multiple sample, the group is called subgroup. Every single day, I collected a subgroup of data from Sivakumar. So every subgroup will have a mean. Now the advantage is my prediction will be much better about Sivakumar. All of you are with me?
Yes, sir.
You can see, if you want more accurate information, you have to work hard. You have to spend more. Taking 1 reading is easier because 1 reading, sugar test, it is going to cost us. It may cost you 50 rupees. 3 readings, it will cost you 150 rupees, isn't it?
Yes.
You need 3, what you call the test strip and all those things. So more the effort, more will be the understanding, and you will be more closer to the reality. And now 30 average I have. Can you calculate a standard deviation or using these 30 averages? All of you have to very carefully watch my words. In the first case, we simply took 30 readings and we simply calculated standard deviation. Now also the procedure is same, but your data is not individual data. Your data is, every data is an average. Do you get my point?
Yes.
Now calculate the standard deviation of the everyday's average. Please answer my question. How many average you have?
30.
30.
30 average.
And now use this 30 average data and calculate a standard deviation. That is called standard error of mean. How many of you understand?
Oh, okay, sir.
Earlier, your standard error was higher, you see, 2.3. Now it has reduced. That means your prediction is going to be more accurate.
Yes, sir.
Now I will say our Sivakumar's sugar level is not between 85 and 115. I will say between 97 and 103. Because how much is the standard error? Close to 1.
Not 6. Yes, sir.
So 3 times 3 into 1. It's almost plus or minus 3. So 100 is the average. Let us say I got 100. The average sugar level is 100. So I will say Sivakumar's sugar level is 100 plus or minus 3. 90 confidence level. My confidence level is 99.73. Why do I say 99.73? I multiplied the sigma by 3. 3 on the right side, 3 on the left side. Now what is my confidence level? 99.73. Suppose I multiply by 2 both sides. I am saying that Sivakumar's sugar level will be 98 and 102. Between 98 and 102. Now what is my confidence level?
95.45.
Beautiful. So when you have more standard deviation, your confidence level will be higher. But when your confidence level is higher, your interval will be wider. How many of you understand this? In any business, we want to be more and more accurate. We want to be more and more accurate means we want to have the interval narrower. At the same time, we need a higher confidence level. How many of you get this statement? We want to make statement using higher confidence level. At the same time, our confidence interval should be narrower. All of you get my statement?
Yes, sir.
Yes, sir.
Yes, yes, sir.
Yeah, when you see confidence level, whatever confidence level you want, you can simply multiply number of standard deviation. Let us say I need 68% confidence level. Then what will I do? Plus or minus 1 sigma. Isn't it? When I say 68% confidence level, people will obviously know I will be correct only to the extent of 68%. 68 cases, whatever I am telling will happen. But 32 cases, whatever I am telling may not happen. But this percentage is not holding good. The industry standard is 95% confidence level you should always get. So you should always have plus or minus 2 standard deviation both side of your mean. Plus or minus 2 standard deviation on both side of your mean, because plus or minus 2 standard deviation will give you 95.45% confidence level. All right?
Right, sir.
Now, again, when to use standard deviation and when to use standard error. I gave you 2 cases. First case, only 1 reading taken from Shivakumar. That time, what should you use to find out your confidence level?
Standard deviation.
Second month, every day 3 reading. Now, which one I should use to calculate the confidence level?
Standard error.
Now the confidence level is, now the confidence interval is confidence interval for the subgroup mean. You just have to add the value, add the term mean. Earlier it was individual observation. For the second case, it is mean value, right? The mean value is expected to fall within your confidence interval because I have used the standard error of mean in place of standard deviation. But all other things remain same. Plus or minus 3 sigma means plus or minus 3 sigma. Please note, for 95% confidence level for both sides, you must use 1.96, not a 3 or not a 2. 1.96 plus or minus 1.96 standard error, right? For individual value, that's for individual data, which is called sample, we will use plus or minus 1.96 sigma. For mean values, we will use plus or minus 1.96 standard error of mean. Clear? Yeah. All of you?
Okay. Only this 1.96 new terminology is coming now.
No. See, when I go up to 2, what is your understanding of normal distribution? 95.45, isn't it?
45, correct.
But I want to round it to 95.
Okay.
So
right.
I will slightly come inside, isn't it?
Understood.
So 2 becomes 1.96, right? All right. And now, one of you tell me what is variance? One of you tell me what is, and I don't understand why all of you are hiding your face. This is not a class, and feel free and interact also. Just those of you who are in condition to show your face, please show your face, and then also talk. Right? Tell me what is variance here. See, you can make mistake. Why are you thinking 10 times to make a mistake? You make a mistake. What is variance here? You are not going to learn that.
Yeah, it's a variation. Actually,
yes, variation only. Variance is another form of variation, correct? And this was taught you on day 1.
Square root of variation is standard deviation. That's
beautiful. Square root of variance is standard deviation. So square of standard deviation is variance.
Correct.
Right? So square is 2.368 to get this variance. Clear? All of you?
Correct.
Yes.
Very good. Yes. So if you have variance, you can get standard deviation. If you have standard deviation, you can have variance. Now, one of you tell me what is this summation means? Sum means 1 hour is not sufficient.
Adding mean, submean, everything summing up.
Summation means addition.
Yes, sir. Addition.
You add all your readings. That is the sum.
Yes,
I am not showing the data here. So you simply explain with some assumption, right? You add all the data, you will get sum. Is that clear to all of you?
Yes, sir. Yes, sir.
And now minimum. What is minimum?
Minimum value.
Very good. 30 readings, we have corrected the sugar level. And whatever is the minimum value, minimum sugar you observed. And in this particular data, minimum is 1.
Okay, sir.
And now come to maximum. Maximum means the maximum value in your data.
10 in
Right?
about data. Yes, sir.
Whichever value is maximum, that is called the maximum value. The highest value. And now can you explain, one of you explain what is range?
Maximum minus minimum.
Beautiful. Maximum minus minimum.
Yes, yes.
Very good, right? And mode equal to 3. What does it mean? Mode equal to 3?
Highly repeated number.
A particular number repeated many a times. I'm sorry. The data is available here. See here. The data is available here. Yeah, none of you reminded me, right? You sum this, you will get 46. And minimum value, you see here, 1 is minimum.
1.
Maximum is, see here, 10 is maximum. And range is difference between maximum and minimum. And now mode is 3. Why do I say mode is 3?
Repeat
I can see 3 many a times.
4.
4
median
times.
mode, right?
Median is not mode. Median is different, mode is different. But 4 times the 3 occurred, and that is called N for mode. Now coming to median. Median is nothing but Q2. See here median. But in this case, your median and mode are same. But definition is different. Definition is different, but in this case, mean and median are same. If you want to find out the mean or median, let me go to the next slide. Oh, sorry, here I don't have. If you want the mean or median, you want the median, you arrange the number in increasing or decreasing order.
Descending or descending.
After arranging the number in increasing or decreasing order, find out which number comes in the center. If 2 number comes in the center, take the average. Do you understand?
Yes, sir.
If there are even number, probably 2 will come. In this case, 2 3s will appear in the center.
Yes, sir.
Now what should you do? You take the average. Average of 2 3 is 3 only.
3.
That is called median. So median is a point which will divide your data set into 2 halves. Clear? Yes,
sir.
or no?
Yes.
All right. So note down all these number, all of you, please. Write down all this number in a piece of paper.
Yes, sir.
Please note it down and you calculate all these things by yourself and show me the calculations you have done. Let me know on this, right? Maybe you can just, in a white paper, you just write and calculate as many statistics as possible by hand yourself and share me the picture of your calculation. Clear? Through WhatsApp, a small assignment, task. All of you will be doing it?
Yes, sir.
But only one is saying yes. How about others?
Yes, sir.
Please do it, all of you, right? Because talking is easier, doing is difficult. So write down the number. Sum means you should literally count, add, and write the value, right? And also you can try the other things which I have not explained, but I would definitely explain if you participate more, right?
Yes, sir.
Yeah, I'm not saying that you should do it now itself, right? You can do it at midnight also, after 1 o'clock, 2 o'clock, or early morning, up to you. You choose. All right.
So the T or mean?
Yes.
T or mean?
TR mean means trimmed mean. TR mean means trimmed mean. You know trimming?
Yes, sir.
Small portion we cut it. For example, we go to salon to get our hair trimmed, isn't it?
Yes, sir.
Same way our mean is right now 3.833. So I'm just trimming it and I'm rounding it. I'm rounding it not by adding, but by trimming. So approximately it is 3.5. Clear?
Okay, sir. That means we have not make it 4, right?
4 means that is called rounding. Trimming means you must reduce.
Okay, sir.
Clear?
Yes, sir.
All right. So now you have studied the a signal point over a period of time. And now you are the district collector or, the in charge of the district. Now you are giving a recommendation to construct a beautiful flyover like this. And the government is asking, if we construct this kind of flyover, what will be the benefits? Will you be able to answer?
Yes, to reduce it, overcrowds, traffics.
Yeah, you people know, people can overcome the traffic. And how many people will get benefited, isn't it? Will you be able to make some judgment?
Yes, sir.
Definitely, right? So earlier, the study what you conducted is descriptive. Now, all your answers to the government is inferential statistics. Do you understand the difference between descriptive statistics and inferential statistics?
Yes,
Yes,
sir.
sir.
So see, earlier you studied the population and then described it. Now you studied a sample and you are judging the population. Do you understand the difference?
Yes, sir.
Earlier, you studied the population by collecting data from it. Again, data is again a sample only. And then you described the population. Now, by having some sample data, you are trying to predict the population. Population is, the future, isn't it? How many people are going to get benefited? And you are making a judgment and proposing to the government now itself. This is called inferential statistics, right? Inferential statistics means the unknown characteristics of the population you are judging. Do you understand? The unknown characteristics of the population you are now judging based on the known characteristics from the sample. Is that clear?
Yes, sir.
All right. So that is why data is very important. That is why data should be free from error. If your data is contaminated with error, your predictions will also go wrong. Am I correct here? Right? So don't allow
Yes.
your data to get contaminated with error if you are really interested in making an accurate prediction. See here. Can one of you read out this statement? One of you can you read out this statement?
As in previous example, 3,000 vehicles have crossed the signal point during peak hours. 45% of them passenger cars, 20% of public vehicles, 35% of two or three wheelers.
Very good. So this report is descriptive statistics, isn't it?
Sir.
This report
Yes,
is
sir.
descriptive, right? So descriptive methods are the methods of organizing, summarizing, and presenting data in an informative way. If you use data to summarize the characteristics of a population, your approach is called descriptive statistics. An average person spend $1 or $3 on a Valentine's Day. How much do you spend on a Valentine's Day? You don't spend nowadays, right?
Yes.
Nowadays, no.
Nowadays, no.
No holiday, sir.
Yeah,
no holiday.
Maybe before marriage, on an average, on a Valentine's Day.
But no holiday, sir.
Yeah, no holiday.
1,000 rupees.
1,000 rupees, right?
Yeah.
So how do you know on an average people are spending 1,000 rupees before marriage? This is descriptive, right? This is descriptive because you have seen the cases. You have seen the cases on an average people are spending 1,000 rupees, right? And in US it is $1 or $3, something like that. Now, yeah. Can one of you read out the last para?
Yeah, random sample of 1,260 marketing graduates from a 4-year school showed that mean starting salary was $42,694. We therefore estimate the mean starting salary for all marketing graduates of 4-year institution to be $42,694.
Okay. So what is that statement saying? So far, you studied marketing graduate students in a particular institution, and the average salary was $42,000. And now you have decided to admit your child in that college. You know why? You are now thinking that your child will also get at least $42,000 salary when they pass out, isn't it? When he pass out.
Yes, sir.
So now you are predicting the characteristics of a future population. Do you understand? So the known information is used to predict the future population. This is descriptive or inferential?
Inferential.
Inferential.
Very good, right? So you got it. And now coming to the sports field. See here Virat Kohli. All of you know Virat Kohli, right?
Yes.
Very good. So his batting average is 59.62. How many matches he played? Hundreds of thousands, maybe 1,000 matches.
No.
Maybe.
No.
How many one-day matches? Few hundred matches.
Near to 200 to 250.
All right, right. So all the matches added and divided by the number of matches gives 59.62. How is this information helpful to you? If Virat Kohli plays in the next match, what is the score you can expect from Virat Kohli? Can one of you tell me? Virat Kohli's batting average is 59.62. Virat Kohli is going to play the match tomorrow. What is the score you can expect? Can you expect 100 from him tomorrow?
No, sir, it's 20.
59 or above.
At least he is saying, 59 or above. But my question is, why not below 59? Below 59 also possible, right? So my doubt is average plus or minus some value is going to be the score of Virat Kohli in the tomorrow's match. But finally, God only knows how Virat Kohli is going to play tomorrow, isn't it? We are only predicting. All of you are with me?
Yes, sir.
Yes, sir.
Tomorrow, in case suppose Virat Kohli become ill, he may not even play the match. Uncertainty is always there. Tomorrow Virat Kohli can got out in the first ball also. Tomorrow Virat Kohli can score 200 also. All possibilities are there. But the major possibility, maximum possibility is there to score around the average. All of you are with me on my statement?
Yes, sir.
Yes, sir.
Average will have the higher probability. Please understand. That is the beauty with average. Average will have the higher probability. See, all of you use bike?
Yes, sir. Yes, sir.
You are using bike to go to office, isn't it?
Yes, sir.
We expect that we always reach the office safe. Am I correct?
Yes, sir.
Why? Because our process is designed in a way that we always reach the office safe. We design the process in such a way. That means the probability of we reaching the office safe is designed to be higher. Does it mean no risk is involved when we are traveling? Risk is there. Am I correct or not?
Yes, sir. Yes, sir.
But we designed the process in a way that, the probability of reaching the office safer is higher. And I'm telling you, average will have the highest probability. Whichever is having the highest probability, mostly that will happen. Mostly that will happen, right? So you can say Virat Kohli will score 59.62 plus or minus. And see here, plus or minus 1.96 standard deviation. Do you remember why 1.96 is coming here? Yes or no?
Yes, sir. Plus
Now
one
let
is
us say Virat Kohli played 200 matches. With all 200 runs, 200 match score, I will calculate a standard deviation. And suppose if that standard deviation is found to be, let's say 3 point something. So, close to 5. Then what will happen? 59, approximately 60, plus 2 times standard deviation. So 70 minus 2 times standard deviation 50. So I will boldly say I can expect a score of between 50 to 70 when Virat Kohli is playing tomorrow. This is called my confidence interval. Do you now understand how did I calculate confidence interval, all of you?
Yeah, but this is with the two standard deviations you collect.
2 standard deviation, and to be precisely 1.96 standard deviation.
So 95% confidence.
95% confidence level. Very good. Beautiful. Okay. Suppose next tour, you know, tour means India will play England 5 matches. India will play England 5 matches. And now I am asking you, what will be the average score of Virat Kohli in the next tour? Do you understand the difference in my question? I am not talking about the next match. Now I am talking about the next series. The next series, how many matches Virat Kohli is going to play? 5. What will be the average score of those 5 matches?
About 60.
Now your prediction is on the average, not on the individual score. Do you get my point?
Yes, sir.
Now the 5 matches Virat Kohli is going to play is called a subgroup. You are trying to predict the subgroup average. Now you can go for plus or minus 1.96 times standard error of the mean. Do you understand understand the application of standard error of mean?
Yes, sir.
You have five scores of Virat Kohli.
Okay, sir.
And the average of the 5 will fall between 2 values. And in order to find out that, the formula you need to use is whatever is the average, you calculate plus or minus 1.96 times. Here it is standard error. Do you now understand how the standard error is now coming to application?
Yes, sir. Yes,
and the formula for standard error is standard deviation divided by square root of n. You know what is n here?
Number of
matches.
Subgroup size. How many matches he is playing in the series?
5.
Very good, right? So all of you are very clear when to use standard deviation and when to use standard error of mean.
Actually, I have one doubt, sir. Actually, this when we predicting that will be 5 matches, but standard error of mean when we calculating, we should take matches already played, you know, sir. That is what we should take, right?
Yes. See, in both cases, only after the matches are played, you will be able to calculate standard deviation or standard error of mean. You will be able to calculate only after the match is over. But see, for example, you have taken a sample. You have taken a sample of 5 matches. You have taken a sample of 5 matches, and you found that the sample average is 59.62. Sample average is 59.62. Now, I am not trying to find out the score in the next match. I am trying to find out the average score in the next series.
Yes, sir.
Average score in the next series. Now, should I go for standard deviation or standard error of mean to find out the confidence interval?
Standard error. Standard error
of mean.
Yes, sir.
Hope all of you understood, right?
Yes,
please
sir.
note, whenever you are taking multiple readings, you should use standard error of mean. Right? If you are not taking multiple readings are called subgroups. Multiple readings are called subgroups. Then use the subgroup size, calculate the standard error of mean to find out the confidence interval. Okay, you can maybe take some time to digest the learning, and that's how it is. Clear? I need otherwise that is why I generally don't teach statistics too much. If I teach too much, then what happens? People will stop speaking, and already Santosh also going to sleep.
No, sir.
No.
Okay.
Actually, we love the statistics. Actually, we want to do the prediction.
But how do I know whether you are loving or you are crying on the other side? I don't know unless and until you speak, right? I only understand seeing the face of Santosh. All right. So now So you can stop me whenever you feel sleepy or it is boring. You can stop me.
No, sir. No,
and then
sir.
we
No,
can wind
sir.
up. Right. So what we learned so far, the accuracy of inference depends on the variation in the data. Accuracy of inference, tell me which will be more accurate. Predicting the average will be accurate or predicting the single score will be accurate?
Average.
Average.
Predicting the average is more accurate, right? And that is why we take most of the time, we take decision using average and try to use the confidence interval for the average. All right.
Yes, sir.
So accuracy of inference is a function of variation, right? And confidence interval, you can use standard deviation of data. You can use standard deviation of data, or you can also use standard error of the mean. You know when to use both, isn't it? I have told you right now. And anyway, both are error, and standard error of mean will definitely be lower than standard deviation. Standard error of mean will be definitely lower than standard deviation. So that is why I suggested go for the second case. So anyway, lower the error, narrower will be the confidence interval. Narrower the confidence interval, people will appreciate the way you are taking decision. For example, I want to know what will be your score in the upcoming exam, green belt exam. Right? Santosh Kumar, what is your gut feeling? What could be your score in the black belt exam or green belt exam?
Above 70%.
Above 70. So his gut feeling is 70 to 100. 70 is the lower confidence interval, lower confidence limit. 100 is the higher confidence limit. That means he is targeting for 85 marks. He is targeting for 85 marks. Finally, he will land somewhere between 70 and 100. Now, what is your confidence level in scoring between these two? Are you confident 90%?
Yes, sir.
90% confident, but still 10% risk is there. He may score above 90 also. He may score below 70 also. Something like that, right? So, risk is there. But if I say, all of you will score between 0 and 100, will it happen?
100%
Yes.
will happen, sir.
100% it will happen. So, my confidence level is 100% because my confidence interval is wider.
Broad. Yes.
You don't require any statistics to keep your confidence interval much wider.
Yes.
You require statistics only to bring the confidence interval narrower. Do you all understand why we need statistics? We need statistics only to bring the confidence interval narrower. Because even a layman can say you will score between 0 and 100. You don't have to be a statistician. You don't have to be a green belt or a black belt. All of you understand why we study stats?
Yes.
Very good. So narrower the confidence interval, conclusions will be more accurate, meaningful, and people will start appreciating your decision. Right?
Yes, sir.
All right. You want me to proceed further? Already the committed time slot is over. I actually planned a small case study. Shall I show you the case study, all of you?
Yes, sir. Yes, sir.
Yes.
All of you please confirm because you have your
Yes, sir.
dinner, your
Yes, sir.
family
Yes,
is
sir.
waiting. Right. See here. Now I'm going to talk about an important topic. This we teach only in the analyze space. Every time we teach statistics and the important thing, the complicated tools, people struggle a lot. So learning it little in advance will definitely keep you comfortable during the analyze space. Statistical significance. See here, there is a player whose confidence limits are between 55 and 65. There is another player, his confidence limit is 57 and 63. There is one more player, confidence limit is between 25 and 40, right? And these players are, the first one is Virat Kohli, the second one is Rohit Sharma, and the third one is Ajay Jadeja. Now you have to choose one out of the three for the next tournament or next series. Now whom you will choose?
For better average, we need to choose Virat Kohli.
Virat Kohli, sir.
Better average, Virat Kohli.
Virat Kohli.
And are you deciding like a common professional or are you using your statistical knowledge?
Common.
Common. This is quite common, right?
Common.
The average is higher and you chose Virat Kohli. But
Yes,
now
sir.
let us talk like a statistician. And definitely it is not the choice of Jadeja because his average is far, far away.
Yes,
But between Virat Kohli and Rohit, look at the difference in the average. Do you really mean to say Virat Kohli is better than Rohit? Are you sure?
No, sir. Almost both are same.
Almost same. Though there is a difference you could see in the number, still the reality can be completely opposite. Am I correct here? The next full tournament, every match, Rohit can dominate Virat Kohli. Rohit can play much better than Virat Kohli. Possibility is there simply because the difference is almost same. Difference is very less, isn't it? But we could easily understand Jadeja is not in form based on the recent study. The Jadeja is found to be out of form, so his chance of playing better is very low. So you may not choose him. But now Virat Kohli and Rohit, if you are in the selection panel, how you should decide is you must recommend both of them. Don't show any partiality. You understand my point? If you are conducting the interview panel, 2 people have scored mark like this. 3 people have scored mark like this, but you need only 1. What decision you will take? You will probably choose 59.33. Am I right?
Yes, sir.
Then you are a normal professional. But if you choose both of them, probably go for another round, you are the ultimate. Do you get my point?
Yes, sir. Yes, sir.
Yes, sir.
This is how you should think. Why? Because why we are going for one more round? We don't really see this difference as significant. The difference is not at all a difference in real life. Do you understand?
Yes, sir.
The difference, see, a difference to be a difference should make a difference in real life. Do you understand my statement? A difference to be a difference should make a difference in real life. So,
yeah, understood.
Yeah, so don't take risk by saying that Kohli is better than Rohit. Rather, you recommend both simply because the difference is very, very small. This is called identifying statistical significance. This is called identifying statistical significance, which means always there will be a border. Always there will be a border. Do you know there is a border between India and Pakistan? Yes or no?
Yes.
Only if someone crosses the border, he will be, given a special treatment, isn't it? If you are in the border, okay, some warnings will be given, and you can be sent to your respective country. But if you actually cross the border, then consequences will be different, treatment will be different. Similarly, we will also take the decision only if our statistics crosses the boundary. And here my doubt is, both the values are, are in the boundary only. So that is why, we should not differentiate them. So Virat's performance is better than Ajay Jadeja. Definitely. This statement is statistically significant. You are right. But next conclusion. Rohit's performance is better than Ajay Jadeja. This is also statistically significant. But conclusion 3. Virat's performance better than Rohit. How many of you accept this statement? We are not going to accept, isn't it?
Yes, sir. Yes, sir.
We will say more or less same. If somebody says more or less same, then I will accept. So that means you are not able to accept the statistical significance here. There are tools, there are statistical tools to understand the statistical significance. The important tool is p-value. Other tools are G-score. Do you know G-score? Z-score? Z-score? T-score? F-score?
T-score, F-score, I know, sir.
T-score, F-score, Z-score, chi-square score, many scores are there.
Correct.
Depending on the type of distribution. If the distribution is normal, the score is called Z-score. At a 95% confidence level, if the Z-score goes beyond 1.96, I will consider the difference as significant. Do you understand where from 1.96 comes? At a 95% confidence level, for a two-tailed study, two-tailed statistical test, I will consider the difference as difference in real life, which is called the statistical significance, whenever my Z score goes beyond 1.96. You get my point, all of you?
Yes, sir.
To make the same statement for a 99.73% confidence level, my Z score should go above 3. Am I correct here again?
Correct.
Yes,
Correct.
yes, sir.
Beautiful, right? So general standard is 95% confidence level. For a 95% confidence level, your Z score should cross 1.96. Whenever you see your Z score crossing 1.96, whatever difference you are seeing, that will also be a difference in real life. Otherwise not, right? So this, and instead of calculating Z score, F score, T score, many score, to avoid the confusion, nowadays, the new tool popularly used is p-value. What is that? P-value. P-value means probability of significance. If the p-value is less than 5%, whenever the p-value is less than 5%, we consider the difference as significant, otherwise not. P-value less than 5% means Z has gone beyond 1.96. All of you understand?
Yes, sir. Yes, sir.
P-value less than 5% means Z has crossed 1.96. So till Z has not crossed 1.96, then what will be the p-value? Can somebody answer this question?
Above 5.
Come again?
Above 5.
Beautiful, beautiful. We all must clap for Suresh.
Yes, sir. 5%.
We all must clap for Suresh, because I have
Yes,
not
sir.
drawn any drawing. I'm talking statistics now.
Yes,
Difficult
sir.
to follow, but you could follow. Please, all of you, listen here. So now, let me draw a normal distribution curve. Do you see a normal distribution curve?
Yes, sir.
Yes, all of you?
Yes, sir. Yes.
Yes.
I'm drawing the center line. What is the area to the right of center line? 0.5. Am I right? 0.5 on the right, 0.5 on the left.
Okay.
Right. Now, I draw a line which is at 1.96 standard deviation from the center. Center is mean. Center is mean, mu 1.96. So Z equal to 1.96. Z equal to 1.96 means out of the 50, see here, yeah, out of the 50%, this side also, see here, this side also. This side is plus 1.96, this side is minus 1.96. What is the area left out beyond 1.96? I mean this area, question mark, and this area. What is the area left out? The shaded area is 95%, am I right?
5%.
So this is 2.5.
2.5, yes, sir.
So this is 2.5.
Yes, sir.
P-value is actually measuring the area beyond Z score. How many of you get my point? P-value is measuring area. P-value is measuring area beyond Z score, which is in this case 5%. Whenever you see the P-value going below 5%, below 5% means below 0.05, you can understand your statistics has crossed 1.96. Am I right? Yes or no?
Yes, sir. Yes, sir.
Only when your statistics crosses this 1.96 line mark, P-value can go below 0.05. A very tough concept. If you have understood, nothing like it. So whenever you see the P-value less than 0.05, you can definitely understand the difference as statistically significant. Otherwise not. All right.
Yes, sir. Yes, sir.
So now I will quickly go through the slides and finish so that you can go for your dinner and other things. Right. See, you can make conclusion simply by looking at the data and simply by looking at the graph. If you want to be very correct in prediction, I mean more accurate in prediction, then you must look for statistical significance. Don't just look at the numerical data, look at the graph, also look at the statistical significance. Do you get my point? Don't just look at the data and graph. Looking at the data and graph, you may end up saying that Kohli is the best. In addition to looking at the data, looking at the graph, if you also look at the statistical significance, what is statistical significance? P-value less than 0.05 is statistical significance. If this also happens, then you can boldly say Virat Kohli is better. Your confidence level is 95%, otherwise not, right? And in research and important projects, you must aim for the statistical significance to achieve the desired level of confidence. And now, can one of you read out this statement?
The average number of runs scored by Rahul per innings was 32.5 for the last 50 matches in a year, compared to his benchmark 40 runs per innings.
Yeah, next.
The lower number of run negative affected his team's match result. The team won only 36% of 36% the matches they played in the same time frame.
All of you understand the problem?
Yes,
Rahul was having a batting average of 40.
Yes, sir. Yes.
But
40.
in the particular season, his batting average dropped to 32.5. Mean is shifted. Mean is shifted downward. As a result, your team started losing more matches. Right? They could only 36. They could won only 36% of the matches. That means what percentage of matches they have lost? 64%.
Yes, sir.
Isn't it? Now you are the team coach. What should you do? Your team mostly relies on Rahul's performance. So you must think of improving Rahul's performance. If you are a green belt, you are a black belt, or you are a team coach, will you be able to do this job? Come on. Will you be able to do this?
Yes, sir.
Team coaches, do you remember? Team coaches are highly paid. Am I right?
Yes, sir. Yes, sir.
They are paid higher than the team players' salary. Simply because they have the capacity to analyze and advise the player and advise the team. Similar role you should play as a black belt in your company. You are going to be a coach. You are no more a player. Please understand. Am I right?
Yes, sir.
Very good. So now let us see how we can analyze. We understood the problem. This is the defined phase. Right? This is the defined phase. Now we move on to measure. Innings played, 50 innings. Any match Rahul is scoring less than 40 runs is now considered a defect. Do you understand?
Yes,
The
sir.
definition of defect. See, the definition of defect is applicable in manufacturing, applicable in pharma, applicable in sports, and applicable everywhere. Now, which is considered a defect? Every time Rahul is scoring less than 40, it is considered a defect. How many instances he scored less than 40 out of the 50 matches?
36.
As a result, his batting average dropped to 32.5. His median score is 15. Standard deviation is 39.47, which means poor consistency. Do you understand? Standard deviation itself is 40. Highly inconsistent. I don't know why. Maybe he has, fall in love with the girl and then he is not focused in the match. Isn't it? There is something going wrong and he is not able to focus. He used to be a consistent player, but last 3 months, his performance is at its worst, right? And the DPMO is calculated, and these are easy, methods are there to calculate. Z score is calculated, sigma levels. Z score means now it is sigma level. Sigma level is less than 1. And project goal is to improve Rahul's batting average. All of you understand the goal statement?
Yes, sir.
Yes, yes.
Yeah. And now we go to the analysis. Out of the 50 matches, you are now diving deeper. You are now diving deeper. Out of the 50 matches, at least in 30 matches, he scored below 20. He scored below 20. 14 matches, he scored above 40. And another 6 matches, he scored 20 to 40. Now you want to improve the batting average of Rahul, isn't it? Now you are asking this question. Why was he dismissed so often before scoring 20 runs? Do you understand the importance of the question? Before scoring 20 runs itself, he is getting out. If you have an answer for this question, then mostly he can play well further and then score a bigger run for the team, isn't it? So our now job is to analyze this particular bar. All of you are with me?
Yes, sir.
Yes, sir.
Now, how many matches he scored below 20?
30 matches.
30.
Now, I want you to stratify. Stratify means dive deeper, dig deeper. Now, I am digging deeper. See here. The 30 matches divided into 15, 7, 4, 3, 1. Can you add all the value? 15, 7, 22, 26, 29, 30.
30.
That means out of the 30 matches, 15 times he was caught behind. You know what is caught behind?
Yes, sir.
What is it?
The wicketkeeper caught.
Wicketkeeper caught him. So he was not playing a particular, shot well. As a result, the ball, gets a nick from the bat, and then wicketkeeper catches. So now, out of the 15, see here, 7 times he was caught in the outfield.
Yes, sir.
And okay, 7, 12, 15, just a second. 7, 12, 15, 17, 19, 20. Okay, see here, type of dismissal when Rahul scored below 20 is this bar, this paragraph. And type of dismissal when Rahul scored above 20, this paragraph. Do you understand the analysis? Right side is different.
Yeah, understood.
Yes, sir, understood.
This is giving the situation because both needs to be improved. Right? You
Yes,
see
sir.
here, the previous case, only the middle bar is favorable. This bar also worst, this bar also worst. But within the two, you must advise Rahul to improve this scenario first. We will analyze this later. We will focus the project here. Right? Hope all of you understand what I'm talking. So now this can be your later priority, but this is first priority. So now 15, 7, this thing has come, this thing has come. I have told you, right. So, correct. Got behind, why was Rahul? Okay, now I am going further. Yeah. Out of the 15, you see here, out of the 15, 10 times he was got out while playing the attacking shot. But 5 times he got out while playing the defensive shot. Now tell me, what is his major problem?
Attacking shot.
He is not able to play the attacking shot. Now what kind of attacking shot? Out of the 10, 10 is further stratified. 5 times he got out while playing the hook and pull shot. 4 times he got out while playing the uppercut shot. Once he got out while playing the square cut shot. Now, what kind of training you would like to give it to Rahul if you are his coach? How to play?
Upper, pull, and
very good.
Hook shot.
How to play the hook shot, how to play the pull shot, and how to play the uppercut shot. If you train him well, you know what will happen? His chance of getting out before 20 will come down. Am I correct or not?
Yes, sir. Yes,
very good. So we move on. So the statistics says, so you have actually what happened? You have actually trained him, and now 0 to 25 balls, number of dismissals, and see here. And another this is a kind of hypothesis testing. Most of the time, he got out before playing 25 balls. I mean, before playing 25 balls, he got out 10 times. But once he plays 25 balls, after that, is what do you call? The getting out is reduced, right? The percentage defective is calculated here. Anyway, I don't want to go deeper here. Now let us come here. So see here. The run scored is low. Why? Because the team has done, the fishbone analysis. And there are many factors were considered the critical. I mean, so many factors were brought to the attention of the team. Out of that, see here, pitch condition, batting innings, batting position, bowling style, batting style, type of bat, and all these things were very critical. And out of that, what we are talking about, you see here, we are talking about the batting style.
Batting style.
We are trying to improve the batting style because the data also confirms, it is the batting style which is very crucial. So the project team did not find any difference when batting first or when chasing a target, right? So they analyzed the data, whether Rahul is struggling to chase or, he could play better in the first innings, and they were not able to find out any difference. And also they compared the pitches, flat pitch and then the green pitch. And that also they were not able to figure out any specific difference. And see, I think there is a difference. What was affecting Rahul's batting while playing on green pitches? Rahul performed better on green pitches when he was not required to open the batting and face the new ball bowler. On green pitches, his batting average in fourth position was 52.6 compared to 12.1 when Rahul opened the batting, a statistically significant difference. Do you understand now that they are using the word statistically significant difference? When he was opening the inning in a green pitch, what is the batting average? Only 12. When he comes in number 4, his batting average is 52. So this difference is found to be statistically significant. Now you must advise him to play at number 1 and not at number 1. Particularly when the team is playing in a green pitch. Do you understand?
Yes, sir.
Very good. So bowling style, effect of bowling style. See, everything they are actually doing, a statistical study. How he has played right arm seamer, left arm seamer, and then the left arm spin, that balls played, a number of defective shots and percentage defective shots and everything, they have analyzed and they have found that, he is having problem while facing the left arm seamer. Do you notice here?
Yes, sir. 21%. Left arm,
I'm sorry. If you have all this data in hand with the coach and with all the other advisor, do you think the team will be able to discuss better?
Yes, sir. Yes, sir.
Right? And that is what they are doing here. See here, they are doing a brainstorming discussion. And for every batting style, pitch condition, bowling style. And batting style, what is the problem? Playing with a hook shot and pull shot. Am I right?
Yes, sir.
And pitch condition, what is the problem? Green pitch, particularly playing at number 1. Bowling style, what is the problem? Facing
left arm seamer.
Very good. Facing left arm seamer. With see, you have understood the problem. You have analyzed and then identified the root cause. Can you now talk about the solution? Yes, you are eligible. You are eligible to talk about the solution. And now, you are involving Rahul also. You are involving team captain also. You are involving the other advisors also. And now they were able to give the suggestion, improvement suggestion, and the responsibilities were assigned. And see here, overall the responsible people, the team captain, batting coach, and everyone were given the task, and then Rahul was actually trained, right? And now, see here, now the after improvement, again, Rahul has played, for some number of matches, and the same statistics were calculated, and you can see for yourself how the improvement happened. His batting average has increased from 32 to 49.
Yes, sir.
Median score, standard deviation. Again, I think consistency has to be improved. And number of innings played, 28. Defective innings, 12 only. Look at the DPMO, it dropped. Sigma level, it improved. So what was happening in real life is reflecting in your Z score. What was happening in real life is reflecting in Z score, isn't it? Z score is here, the capability, process capability. That is why, We connect statistics to solve any kind of real life problem, and the percentage defective has brought, came down from 72 to 43, and the improvement journey continued to improve his, batting consistency as well as batting average. This is how you can use statistics to solve any real life problem. Not only improving Rahul's performance, but also you can improve your team's performance and your organization's process performance. All that required is a correct way of statistical thinking. I hope this session you have understood certain important things. The importance of statistical measures like mean, average, standard deviation, variance, and all those things. You also understood the difference between descriptive statistics and inferential statistics. You also understood the difference between a mere difference and statistical difference.
Yes.
Right? And the difference and the meaning of the term statistically significant. The difference will be considered statistically significant only when the p-value is less than 0.05. When your analysis is conducted at a 95% confidence level. All of you are with me on this statement?
Yes, sir. Yes, sir.
Yes. Any questions to me? Any questions?
No, sir.
No, sir.
Okay.
No,
No questions. So can you please, all of you, share your view about your learnings today? Is that helpful? Should we conduct more such sessions or do less such sessions? Because the attendance is, the attendance is telling me that I should not do extra classes. Very poor attendance, statistically significant information.
Yes, sir.
Yeah, please.
We should conduct more and more like this, sir, because we're preparing for analysis phases right now. So very important for us. We may have to have another class maybe on Friday if possible.
Very good. So I said, this, what do you call, next Wednesday also I will do similar class. But what I want is, some attendance, good attendance. Please motivate your team members, because when everyone comes, our job becomes easier and we don't have to repeat unnecessarily. We don't have to repeat unnecessarily. And now at least please give me an assurance that you share this knowledge with your team members, because I am not going to repeat the same story again. Definitely no. So, but this is very, very important. Those who missed, please advise them to go through the recording. Probably I will post this directly in my YouTube channel, and then you can, those of you have subscribed, and they can watch this particular thing from the channel only, because this is not a training session, right?
Okay.
Okay. And one more favor I want from all of you.